Hi, pre-calc guys. Day 2 polynomial, zeros, multiplicity, and end behavior. A zero, another name for that would be a root or an x-intercept. And what that is where your graph crosses your x-axis. All right, multiplicity. Multiplicity is the number of times a particular root 0 x-intercept appears. So number of the same root. For example, if you have x equals 3 and x equals 3 and there's two of them, that would be called a double. If there's one, we call that a single. Now, review your end behavior. That was yesterday's notes. Make sure you have a copy of the chart or your notes available to you because you will need them to do the graphing here. So first of all, it says, given the following, find the zeros and multiplicity. So when you're finding the zeros, remember you said each factor equals to 0 and solve. So I'm going to start with 3. 3 equals 0. Doesn't make sense. Then I have 3 x minus 2's. That's what that 3 means. So that means I have x equals 2, x equals 2, and x equals 2, and then I have 1x plus 4, so x will equal negative 4. When there are 3 of the exact same thing, we call that a triple. When there is just one, we call that a single. And I'll tell you what that means here in a minute. So we're going to plot these zeros. X equals 2. Now I can't put 3 dots, so 1 would be sufficient. And then x equals negative 4. 1, 2, 3, 4. Let's look at the degree. I have 3 zeros and I have 1 more. So that means I have a degree of 4 and my leading coefficient is positive. When your degree is 4 even and your leading coefficient is positive, that means on the very ends you go up and up. Now let's talk about the multiplicity and what that means. If you have an odd multiplicity, 1, 3, 5, 7, when you're graphing, that means you pass through. I'll show you what that means here in a minute. If you have an even multiplicity, that means you bounce back. So, odd, odd. I have my end behavior, so I start here on the left. I need to pass through negative 4 because it's a single. Once you pass through, you can turn around to the next one. And here, I need to pass through there as well because it is odd. So this is a sketch, keyword sketch, of your graph. Let's do the next one. Set each factor equal to 0 and solve. X equals 0, there's just one of those, so that is a single. X equals 5, just one of those, that's a single. X equals negative 2, just one of those, so that is a single as well. I'm going to plot all of those, 0, 5, and negative 2. Now let's look at the degree. The degree is I have 1, I have 2, I have 3 zeros, and my leading coefficient is positive. So odd degree, positive. When it's an odd degree and positive, that means on the ends, end behavior, I go down and I go up. Now let's look at these other points and finish my graph. Single, single, single. That means I pass through all of them. So I pass through, I turn back, I pass through, I turn back, and I pass through. These are all factored for you. Now let's go to the bottom ones here that are not factored. First step is to factor them. So I'm going to take out a greatest common factor of x squared. I'm left with x minus 4. I look in here, I cannot factor that any further, so I am ready to set each factor equal to 0. There are two x's, x equals 0, x equals 0, and x minus 4 equals 0, which means x will equal 4. There are two of these, that's a double, and then this is a single. I'm going to plot those, 0 and 4. My degree is 3. I have 2 and 1 more, so my degree is 3, and my leading coefficient is positive. When your degree is odd and your leading coefficient is positive, that means on the end points, you go down and you go up. Now what's new with this one is one of my zeros is a double. That means you bounce back. So I approach my 0, which is 0, and I hit it and I bounce back. I turn and then I pass through. And I pass through 4 because it's a single. Alright, one more. No greatest common factor. I will cut it in half because when you have 4 terms, you break it into 2 pieces and you take the GCF of each part. So over on the left hand side, I'm going to take out an x squared, and then I'm left with x minus 5. I take x minus 5, I put it on this side, as it has to repeat on both sides. Then I ask myself, what do I multiply x by to get negative 25x? Well, it's negative 25. So I have x squared minus 25 as my first factor and x minus 5 as my second factor. Now I need to make sure it is factored completely. Notice here, this is a difference of perfect squares. So I have an x plus 5, I have an x minus 5, and then I'm going to carry down my other x minus 5. Set each of them equal to 0. X plus 5 equals 0. That means x equals negative 5. There's only one of those, so that's a single. Then I have x minus 5 equals 0, and I have another x minus 5 equals 0. Therefore, x equals 5, and that would be a double because there are 2 of them. I'm going to plot those. So negative 5, 1, 2, 3, 4, and positive 5. My degree is 3, so it's odd, and my leading coefficient is positive. So what that means is on the ends, I go down and I go up. Negative 5 is the first one I come to, and it's a single. So what that means is I pass through it, I turn, and I come to my next 0, which is 5, which happens to be a double, so I hit it and I turn back. Alright guys, I hope you're doing great. I would love to see some of your faces, so if you'd like to hit Google Meets with me, that'd be awesome. Have a great day.